We live in a world of constant change. Look around you. What do you see? Maybe a cup of coffee steaming on your desk, or perhaps the vibrant colors of a blooming flower outside your window. These changes, both big and small, are often the result of something quite extraordinary: chemical reactions. Chemical reactions are the hidden engines of our universe. They are the processes by which substances transform at their most fundamental level. Imagine a magician, but instead of pulling rabbits out of hats, they're rearranging the very building blocks of matter. These reactions are happening all around us all the time. From the food we eat to the air we breathe, chemical reactions are essential for life itself. And while they might seem like the stuff of science fiction, they are, in fact, the everyday magic that makes our world so vibrant and dynamic. To understand chemical reactions, we need to think about the tiny particles that make up everything around us: atoms and molecules. Atoms are like tiny building blocks, and when they combine, they form molecules. Imagine Lego bricks snapping together to create different structures. Now picture these molecules as tiny dancers, constantly moving and swirling around. When they bump into each other with enough energy, something amazing happens. They rearrange themselves, breaking apart and forming new partnerships. This is the essence of a chemical reaction. It's like a grand square dance, where molecules switch partners, creating new and exciting combinations. Some reactions are slow and graceful, like the rusting of iron. Others are fast and explosive, like the ignition of fireworks. But no matter the speed or scale, all chemical reactions involve the same fundamental process: the breaking and forming of chemical bonds, the forces that hold atoms together in molecules. Imagine two friends holding hands. That's like a chemical bond, a force that holds atoms together. In a chemical reaction, these bonds can be broken and new ones formed. Just like our friends changing partners in a dance. When bonds break, energy is required, like needing a little push to separate our hand-holding friends. This is why some reactions need heat or light to get started. Think about striking a match. You need that initial burst of energy from the friction to break the bonds in the match head and initiate the chemical reaction that creates fire. When new bonds form, energy is released, like the happy sigh when two friends find each other in the dance. This is why some reactions release heat or light. Think about a bonfire. The burning wood releases heat and light as new bonds form in the reaction between the wood and oxygen. So, chemical reactions are all about energy and the rearrangement of atoms and molecules. They are the fundamental processes that transform our world, from the smallest cells in our bodies to the largest stars in the cosmos. Section 4. Cooking up chemical changes. One of the most delicious examples of chemical reactions happens every day in our kitchens: cooking. When we bake a cake, we're actually orchestrating a series of chemical reactions that transform simple ingredients into a delicious treat. Heat plays a crucial role in these reactions. It provides the energy needed to break the bonds in the starting ingredients like flour, sugar, and eggs. These broken bonds then allow new bonds to form, creating new molecules with different properties. For example, when we bake a cake, the heat causes proteins in the eggs to unravel and form new bonds, giving the cake its structure. Sugars caramelize, creating that beautiful golden brown color and sweet flavor, and the baking powder, well, that's where the magic of gas formation comes in, creating those airy pockets that make the cake so light and fluffy. Section 5. Rust, a chemical transformation. While some chemical reactions are delightful, others, like rust, are less welcome. But even rust, that reddish-brown coating that forms on iron objects, is a fascinating example of chemical change in action. Rust is formed through a chemical reaction between iron, oxygen, and water. When iron is exposed to moisture and air, the iron atoms react with oxygen atoms to form iron oxide, which is what we know as rust. This reaction is a type of oxidation where a substance loses electrons. In the case of rust, iron loses electrons to oxygen. This transfer of electrons is what drives the formation of iron oxide, the reddish-brown substance we know as rust. Rust is a slow and gradual process, but it can weaken iron structures over time. That's why we often coat iron objects with paint or other protective layers to prevent rust from forming.